Hello everyone, welcome to FP Learning. Today topics we have pump head definition, right? There are several terms which we use with the pump performance condition, which might be net positive suction head or net suction head, static discharge and the static suction head. What are those terms and all? We'll have a look in this video. It's very short video, must be not mu must be a maximum of 5 minutes. So stay tuned, stay updated and subscribe my channel so that you can get the latest update on various FE topics. So let's begin now. Okay, so here we have one of the diagram where we can have a look at all those pump performance definitions, right? All those terms are associated with the pump performance curve, right? So the first one we have static suction head, right? Means here we have a water tanks, and from the tanks it is open to the atmosphere, atmospheric pressure. From here we have some static pressure, right? Static suction head due to the height of the tank, right? So if you apply the formula pressure equals to density gravity into height, based on the height of the tank we can calculate that one, right? So this is our static suction head, right? And now the water is coming here all the way at the inlet flange here, right, of the fire pump, right, at this location. Now we call it net suction head, right? And you can see there is a losses. What are those losses? If you have read it thoroughly, this losses is because of the friction in the piping all the way from the bottom of the tank to the suction flange of the pump. We have some pipe fittings and all. We have the friction losses, right? If you want to have more idea about the friction losses, please see my video on friction loss explained. The links are there in the description box. Okay, so we have a static suction head, and then all the way at the suction flange we have some pressure losses, right? Friction losses due to those pipe and all. And now we have only net suction head. We call it net suction head or net positive suction head if it is positive. Most of the centrifugal pumps need positive suction heads, self-priming, where water enters at the eye of the impellers by itself, by some atmospheric pressure or some other means of downstream pressure. So this is net suction head. There is a definition in the next slide that you can have a look at later stage, but now just focus on the diagram. Okay, now the energy is transferred from the pump. Let's wait a moment. The energy transferred from the pump, right, from here, and here we have a net discharge head all the way up to this point from here, right? This is the net discharge head. Now this is the combination of the head, means the pressure we are getting from the suction tank due to the height of the tank, plus the energy added by the centrifugal pump, the one based on that the impeller design, the capacity of the pump provided by the manufacturer. So this is the addition of the suction head due to the height of the tank plus energy or pressure added to the fluid by the pump, right? So must be careful when you are selecting your pump. Next time be sure about your supply side, means what is the height and what is the pressure we can get at the inlet of the suction flange, because based on those conditions, right, a pump manufacturer can give you a best pump application for your suitable application. This is why we have to be careful regarding the net positive suction head at the inlet. Providing those data to the manufacturers will help a lot, to select you the best pump to meet your demand. Okay, so this is our net discharge head. It is the energy added by the pump plus the height of the tank. And then we have static discharge head, right? Now the static discharge is the maximum vertical distance from the pump center line, from this one all the way to the free surface of the waters, right? This we call the static discharge head, right? And again there is some losses. If you can see, these are the losses. and this losses is again because of those friction loss in the piping based on the pipe materials and all diameters, velocity, and all those defect pressure losses avoid. So this is based on that condition, right? So remember one thing. Now, what is the total head of the pump? Right? The total head of the pump is only from this point all the way to this point. We have to exclude the net positive suction head we are getting at the inlet of the pump, means at the suction flange, because that is the pressure we are getting because of the height of the tank. So we have to minimize that one. The total head, if you define in one word, energy or pressure added to the fire protections to the fluid by the pump, right? So it is the only, we have some pressure at the inlet flange, and then from the motor and all we added some energy, the form of the pressure to increase that one. That we call total head, means what is the head generated by the pump, right? And if you talk about the net discharge head, it is a combination of the total head of the pump plus the head we are getting from the suction side of the flange. This is all about the terms we discussed regarding that one. I hope you understand this one. Let me summarize it again so that we can get idea about this one, right? So here we have, just wait a moment. Here we have atmospheric tank. Here we have a water tanks, and due to the height of the tanks, we have some pressure here, right? In feet or in meters, we can convert to the psi or bar as convenience, but based on the different formulas. And now all the way from this much pressure at here, by coming to the inlet side of the flange, we loses some pressure because of the friction and all. So it comes to the impeller of the pump, and the pump added some energy, pressure, and then it is going all the way up to this one. We call it net discharge head. So this is the combination of the pump performance plus the pressure we are getting from the height of the tanks, right? And then we have the total static discharge head. That is the head we getting after all losses in the friction piping from the pump flanges, pump discharge flange all the way to the top of the free surface of the water, right? So this is all about the terminologies we use in fire protection system. I hope you guys have learned all those, cleared those doubts. But for your memories and for your time to time revision, here is the definition of all those terms so that you can have a look at this one. So here we have the pump head definition, right? Static suction head, we represent this by S script subscript small s, right? So this is H and subscript small s. It is static suction head. What is the definition of that? It used to describe the distance from the center line of the pump all the way to the free level of the liquid surface above the pump. So here we are talking about, and just wait a moment. So this one we are talking about, this is our HS, static suction head, right? And then we have net positive suction head, NPSH or HSB. It must be always the available net positive suction head at the suction flange must be high, must be greater than the required NPSH. That will discuss in some other part of the video. That's a long story regarding the cavitation, water hammer, and to make your pump reliable for long life. We'll discuss at some next video. So here whatever pressure we are getting at the suction flange, we call it net positive suction head, right? As we discussed in the beginning, and now we are discussing. And then we have the static discharge head, right? It used to describe the maximum vertical distance from the pump center line to the point of free discharge. We cross 5 minutes. I was just promised I will not go above 5 minutes, but to describe and all in details takes some time. Better next time I'll try to limit my video for 5 minutes. Wow, what is your thoughts? If you have any inputs or suggestion on my duration of video, you are most welcome to put your comment suggestion to the comment box. You can connect me on LinkedIn and all. And then we have total head, right? Energy or pressure added to the liquid by the pump only, not the pressure we are getting from the height of the tank. Keep in the mind. And the last one, we have net discharge head, which is the reading of pressure gauge at the discharge of the pump plus velocity head at point of gauge attachment. So it is the combination of pump performance, the energy getting by the pump plus the net positive suction head we are getting. So this need to be understand carefully while designing your pump, because if you don't have enough NPSs available and which is required by the pump manufacturer in the data sheet, that minimum we need this much of the pressure at the inlet of the flange, and later on if you purchase the pump and at the side there is different scenarios, then trust me, at the end of the day you are going to regret for those conditions. So that's a part of some other videos, we'll discuss that one. And here we have some of the definitions from NFEA 20. If you want to look in details, you can go to NFEA 20 and you can see all those definitions: net positive suction head, discharge head, and all those other requirements as per your convenience. So this is all about pump head definitions, right? So I discussed about different parts of the terms required to understand the pump performance condition and curve carefully for our project to understand it thoroughly, right? So if you have any comment, suggestion, or any doubt, you can contact me through LinkedIn, Facebook, or you can send me email as given here in the screen. So take care, guys, and see you next time. Please subscribe my channel so that you can get the latest update on various AP topics in the future. Okay, guys. So I see you next time, and take care, and bye bye.